So question 1 of exam 3, we were supposed to fill in the table regarding octagonal, decagonal, and pegonal numbers. So first with octagonal, here are my answers. I found that each time, so you start by adding 7, you then add 13, so you're adding 6 additional from the last level. My n formula for this is n over 2 times 6n minus 4. So I found that the last level is 6n minus 5. And then you subtract this by 1, and that's when you get 6n minus 4. Each rainbow you do with octagonal is going to be 6n minus 4. And that's where you get your n divided by 2 times 6n minus 4. Decagonal, here's all my answers. Now I did the same thing with rainbowing, and I got n over 2 times 8n minus 6. So those are my n formulas for octagonal and decagonal. Pegonal. Now you start with 1 because that's what all the other ones start with. Then P is going to be your n equals 2. N equals 2 has always been the number of sides you have in your shape. Then you go up 3p minus 3, 6p minus 8. So each time I found that I was adding 1 additional p and then 2 additional numbers. So this was plus 5, but this was plus 3. So plus 3, plus 5, plus 7, and then you're adding 2p, 3p, 4p. I found the equation was n over 2 times p minus 2 times n minus the value of p minus 4. So I did rainbow pairs again, and that's where I get my n divided by 2. And then the p minus 2, that's the first number in like this formula. So let's look at octagonal. It's 6n minus 4. 6 is the number of sides minus 2, so 8 minus 2. That's where we get our p minus 2. Then we multiply by the n. So that's going to be 6n. And then we do p minus 4. We found in octagonal and decagonal that the number of sides they have in each, so 8 minus 4 and 10 minus 4, gives us the last number in the pairs that we rainbow. So n over 2 times p minus 2 times n minus p minus 4. Question 2 of exam 3 was to find where the park would be located in Euclidean and taxicab. So Euclidean, I'm going to show this first. I did not draw the circles because 1, I didn't have a compass, and 2, I'd be bad at freehanding, so I'm saving you here by not doing that. So we found their distance. It's 4 to the right and then 4 up. So we get our Pythagorean theorem, and we find that it's the square root of 32, or 5.6568. The midpoint is 2.83. We put a perpendicular bisector at the point of 2.83, which is the direct middle of the distance from Polly-Eyes to the gas station. If we were to show this, like how or where the perpendicular bisector would be and the shortest point, we draw triangles from point A, which is Polly-Eyes, to point C, bisector, point B, gas station, to point C, bisector. So I would draw circles, and then with the circles, you would find that this is where all the points would be, all the equidistant points. Now if we move to taxicab, with taxicab, the distance is 8, so 4 to the right, 4 up, because you're counting each intersection, that's 8. Midpoint of 4. So the midpoint is the radius. I drew a taxicab circle, which is a square, around each point. And I found that there are 5 points where they intersect. Now we go down to part C, and part C I didn't draw, I just described. So I said I would move it to an odd distance because the midpoint would be a decimal. It works for Euclidean, but in taxicab, each point or the park has to be on an intersection, and you can't find where they meet in taxicab if the distance is odd. So again, I did this in part A with Euclidean. You can see that even though distance is odd, it still works. But part B, distance is even, it works. If the distance would be odd, you would not be able to find the 3 of exam 3. We were supposed to find the distance from the boat to the treasure in Euclidean and taxicab. Part A was Euclidean. So here is the boat. Right at the end, I found that it was 17 over and 9 up. So 17 squared plus 9 squared equals 370, which is c squared. Then to find c, you square root it, and you get 19.235. That is your Euclidean distance from boat to treasure. Now, part B was how many blocks, or how close is it? I found that it was 26 blocks from boat to treasure. That is because I took different routes. I just looked at them and counted them up, and it was 26, and that was the shortest one I could find. Now part C was to calculate the different ways. I found that the answer was 2,012,332. So I used Pascal's, and you do, 1 plus 1 equals 2, 1 plus 2 equals 3, and so on. You would count these, and reminder that the water is 0. So you might ask why I have 28 all the way across. That's because 28 plus 0 is 28. 28 plus 0 is 28 all the way across. Now these keep increasing because you're adding these squares, not the outside squares. Like this is the same across because you have to add the outside squares. This is the same up because you have to add the outside squares. So again, if I use Pascal's the whole way across, I get 2,012,332 different ways. And this is my answer for exam 3.